Alright, this particular problem is only slightly different from the one before that I posted in my last video. In the last video we saw a problem set up that had angle, angle, side, where we had two angles followed by a side. Here we're provided with two angles, this angle S and angle R, and the side in between them, the side that's kind of sandwiched between the two. This is what we mean by angle, side, angle. Once you get past that, I really kind of feel a little silly doing another example like this, because mechanically speaking, it's exactly the same. You have two angles given. If you have two angles in a triangle given, you're going to be able to go in and immediately find the third angle by subtracting the previous two angles from 180 degrees. So here, just to save a little bit of mental faculty, you can see here that this is the same calculator from the previous video. We have 180 minus 42 minus 15, and we see that our obtuse angle there is 123 degrees. Well, there we go. We've got one of our three pieces of information that we need already. We still need to find the length of little r and little s, but if you look back to the last video, you'll remember that little r, now keep in mind previously we've seen A, B, and C for our variables, but we can use any combination of letters we want. I prefer that they pick letters that don't look alike in capital and lowercase, but they did not here. We know that little r over sine of big R would equal, for example here we have big Q and little q, so we can go in and say, well look, 16 over Q we found to be 123, this would be sine of 123. And let me go ahead and just write this down here. I was going to shortcut this, but let me actually write it just normally, in case anybody's coming to this without having seen the previous video. From law of sines, we would see this. We would have little r over sine of big R equals little q over sine of big Q. What I did in the last video, though, is I said, look, this guy down here is a problem. We want to get little r by itself. So let's multiply this guy up to the top of this side of my equation. And we'll see that we can already just plug that into a calculator and solve. The good news is this video is even shorter than the last one because I can just parallel that for little s. I'm still going to use 16 and sine of 123. There's nothing wrong with that. But over here, I'm going to have sine of, instead of big R, which I had the 15 degrees here, we're going to have sine of big S, which is the 42 degrees. And this will let me illustrate something I mentioned in the last video, is that if you have a calculator that has heightened functions like this one, if you go in and set up your fraction and say 16 sine of 15 on top, on the bottom you put your sine of 123, always, always, always double check, hit your mode button, make sure you are still in degree mode and that you didn't somehow reset to the radians. And once we get that value, we see it's about 4.94. I usually round to 2 decimal places on default. So about 4.94. They did not give us any units of measure here, so we can stop with the 4.94. We don't need to say inches or feet or anything like that. We don't know. And then all I have to do, thankfully, is I can hit second enter, regenerate that same fraction, and then all I have to do is go to the top here and replace that 15 with 42 instead of retyping in all that other stuff. And we're going to get about 12.77. So that 5 bumps the 6 up to a 7. And there you have it. The problem is very similar to our previous problem of angle, angle, side. Anytime you're working with a problem that gives you two angles, go ahead and find the third angle. There's no reason not to. It's very quick, very simple. That's my preferred first step, although I did not do that in the last video. Once you have all three angles, you can see this nice, neat parallel setup for R and S down here, where you have your 4.94 and 12.77 in no time at all.